Okay, so as I was saying, in this lesson, we are going to focus on quadratic equations. Okay, and quadratic equations have actually they have more than 3 ways in which you can solve them, but the most common ones are the 3. Okay, so the first one is what we call as the factor method or the factorization method. I believe everyone knows the factorization method because it's the one that we most use at grade 12, grade 10, somewhere there. Okay, so where you have to find the factors, the product, the sum. That's what we call as the factorization method. And then we have a very simple method which is known as the quadratic formula. Okay, so you just have to get your A's, your B's, and your C's from the quadratic equation, and then just plug them into that formula, and then you'll be able to get what? Your answer. And then the third one that we are going to talk about, okay, is this one here, okay, the completing the square method. So this one is the one that I see is challenging a bit because it's new, okay, unless you are taking our pure math at grade 12. That's when you can know the completing the square, okay? So we are also going to solve quadratic equations using that same what? Method. Okay, so the question here that's saying solve the following quadratic equations using these 3 methods, okay? Meaning on each of these equations here, we are going to solve it first using the factor method, and then we solve it again using the quadratic formula, and then finally using the what? The completing the square method. Okay, so let's do the first one there, and then we'll see how we shall go. Okay, so the first one there, it has 7x, x squared plus 7x, and then plus 10 is equals to 0. So let's see how we can best solve that one. Okay, so we have this quadratic equation plus 7x and then plus 10. Okay, so we are asked to solve this quadratic equation using what? 3 methods. So we are going to start with the factorization method. Okay, so the factorization method, you just need 3 things here for you to solve a quadratic equation. You need the product, the factor, and the sum. Okay, so you need these 3 things here. Okay, so how do you get this product here? You multiply the coefficient of x squared, meaning a number that is in front of this x squared, multiplied by the constant here, which is 10, the number without any x. Okay, so we multiply in front of this x squared, there's a 1. So 1 multiplied by this 10 is going to give you a 10 as our product. Okay, and then our sum is this guy here. Okay, the 7, the coefficient of x, that's our sum. So we are going to put 7 there. Okay, and then now we come and find the factors. Okay, so by factors, we just simply mean 2 numbers such that when you multiply those 2 numbers, they're going to give you what? 10. And then when you add those 2 numbers, they're going to give you what? A 7. That's what we mean by factors. Okay, so what factors can we use such that when we add them, they give us a 7, and when we multiply them, they give us a 10. Anyone who can try? What factors can we use here?
Five and 2.
Yes, okay, so that's correct. So we can use 5 and 2. So we see that when we add 2 and 5, we get the 7. And then when we multiply them, we get the what? The 10. So it means those factors work. Okay, so what are we going to do now from there? We are going to write this sum here, okay? This sum here, the 7, we are going to write it in terms of these 2 factors here. So we are going to say x squared plus, okay? This 7x, it can be written as 5x plus 2x, okay? It's still 7x, but we've just separated it into 2. And then we say plus 10. And this should be equals to what? To 0. Okay, so we see that now we have an expression that has got 4 terms, okay? So we have to group these terms now. So this will be grouped with the 5x, and then this plus 2 here will be grouped with the 10, okay? And then once you group them, you factorize what is common, okay? So you look at this number and this number, you ask yourself, what is common? Okay, we can see we have an x here, we also have an x there. So we are going to say the x goes outside the brackets. Then inside, if I remove an x here, I'm going to remain with x plus, if I remove an x here, I'm going to remain with what? 5. But then you close. Okay, and then on this side, you ask yourself again, which one is common? So here I have 2x, and then here I have 10. So we see that these 2 here can go into the 2x, it can also go into the 10. Okay, so it means the 2 is the factor, it can come out, and then in the brackets, we are going to remain with x plus 5. And then we say this should be equals to what? To 0. Okay, so it's very important to note that the factors that you have in your brackets here, when you're using the factorization or method, should always be the same. Okay, should always be the same. If they are not the same, it means you've gone wrong somewhere. Okay, so make sure that these two are the same. So it means now we are going to have x. This x that is outside is going to combine with this plus 2. So we are going to say x plus 2. And then we have the same things there. So we just write it once as x plus 5. Okay, and then this should be equals to 0. And then we solve for x. Okay, so this x plus 2 can be equals to 0, or the x plus 5 can be equals to 0. So we're going to get two answers. So x plus 2 is equals to 0 will give us the first answer. And then x plus 5 is equals to 0 will give us the what? The other answer. So this is going to be x is equals to minus 2, or we can say that my x is equals to what? Minus 5. Okay, so it means we have solved our quadratic equation there. Okay, we have been able to come up with two answers there. Okay, so any questions there, you are free to ask. Any questions there, you are free to ask. Okay, no question. Okay, so we solved this one here. We were using the factorization method. So now let's solve the same question, but using the quadratic formula. We see that it's going to give us the same answer. Okay, so what was my equation? My equation was x squared plus 7x and then plus 10 is equals to 0. Okay, so it's very important to know the general form of a quadratic function. Okay, so the general form is ax squared plus bx plus plus c, okay, is equals to d. This is a general form. Okay, so whenever you are given a quadratic equation, it means you can recover your a's, your b's, and your c's and your d's. You can get them back. Okay, so we see that the a is just the coefficient of x squared, the b is for the x, then the c is the constant. So if I was to get my a, my b, and my c from this equation that I have on top there, okay, to be a is equals to, what is the coefficient of this guy here? Just be 1. And then b is equals to, the coefficient of this 7x is actually 7, and then c is just 10. Okay, so once you get your a, your b, and your c, and then now you use the quadratic what? Formula. Okay, so quadratic formula is x is equals to minus b plus or minus the square root of 7 squared minus 4ac. Okay, and then we divide all this by what? 2a. So this is the quadratic formula. I'm sure you know it. Okay, I'm sure you know this. So we're just going to substitute now the values. Where we can see a b, we are going to put 7. Where we can see a c, we are going to put 10. Where we can see a, we are going to put what? 1. So let's substitute, and then we see what we are going to have. Okay, so I can say my x is equals to minus, and then I put b, which is what? 7, and then plus or minus the square root of b squared. So here we're going to say b squared is just 7 squared minus 4. My a is 1, and then my c is what? 10. Okay, and then all this we are dividing by 2a. A is just 1, so it means this is just 2, 1 like this. So it will just remain what? 2. So we have something like this. Let's simplify it. So we have a -7 plus or minus, and then inside here we can do the multiplication. So what is 7 squared? Okay, so 7 squared is 49. So you're going to put your 49 there, minus, what is -4 multiplied by 1 to be -4. Then that -4 multiplied by 10 to be what? 40. And then we are dividing all this by 2. Okay, so it means what do we have here? We have -7 plus or minus, and then inside here, under the root here, we're going to have 49 minus 40. Okay, so 49 minus 40 is the same as 9. Okay, so it means here we have the square root of 9. And what is the square root of this 9? Square root of 9 is just what? 3. Okay, and then we're dividing all this by 2. So it means now from here we can see that you are going to have 2 answers, right? So the first answer will get the positive sign here. So it will be -7 plus 3 divided by what? 2. And then the other one will be this. Be -7, and then you get the minus sign here, which is -3 divided by what? 2. Okay, so these will be our 2 answers. So this will be -7 plus 3, which will be what? It will be 4, right? Okay. So this will be -4 on top divided by 2, which will just be what? -2. So our first answer -2. And then here to be -7 minus 3, which will be -10 divided by 2, which will just be what? -5. Okay, so we can see that we are getting the same answer. These are the exact answers we got when you use the what? The factorization method. We have also gotten the same answers after using the what? The quadratic formula. Okay, if there are any questions there, you are free to ask. Okay, no question. Okay, so now let's solve this same question, but using the completing the square method. Okay, so let's look at the completing the square method. So I have x squared plus 7x and then plus 10. And then I want to use completing the square method. Okay, so listen carefully, guys. The completing the square method, it's very simple. You just have to follow the rules. Okay, all right. So the first rule is that before you use the completing the square method, always make sure, okay, that the coefficient of this x squared here is 1. Okay, always make sure that the coefficient of x squared is 1. Okay, so we can see here that the coefficient of this x squared is indeed 1. So meaning we can use completing the square. So how are we going to do completing the square? We're going to say, I write the same thing, x squared, okay, and then I write plus 7x, okay, and then after this plus 7x, I'm going to say plus, and then I'm going to write what we call as a special 0, okay. So what is a special 0? It's a 0 that is expressed in terms of numbers, okay. It is a 0, but it is expressed in terms of numbers. So for example, when I say 5 minus 5, 5 minus 5 is a 0, but it's expressed in what? Numbers. So that's what we are going to do. So now, how do we write that special 0 when we are completing the square? Okay, we are going to say, I'm going to divide the number here, the coefficient of x. Okay, I'm going to divide the coefficient of x by 2, and then I'm going to square it. Okay, so this is what I mean. So you get the coefficient of this x, you write it, and then you say divided by 2. Okay, and then you do what? Square it like this. Okay, and then you get this same thing here, okay, but with a different sign here. You say minus, and then you write the same thing again, squared, okay, and then you add this 10 now. So you're going to say plus 10 is equals to what? To 0. So what have I changed in this equation? Nothing, okay, because I've included what we call as what? A special 0. We see that these two guys here, they are the same and they have opposite signs here. So meaning it's just a 0, okay? So it means this one here represents a what? What we call as a special 0. Let me put it in a box. Okay, so this guy here that we've added here, it's the same as a 0, but we are just writing it in a what? A special way. Okay, so once you write the special 0 there, okay, you'll realize that you form what we call as a perfect square now. Okay, so a perfect square is formed by the first 3 terms in the equation. Okay, so this is the first term, second term, third term. So these ones now that I'm going to highlight in yellow, these ones here, okay, they form what we call as the perfect square. Okay, so a perfect square, you can simply write it as the following. Okay, you get x here without this squared, you put it down, you write x, okay, and then you get whatever is inside these brackets. Okay, you say whatever is inside these brackets with the sign that it has. So this is plus 7/2, okay, and then you put these 2 in brackets like that, and then you say squared. Okay, so all this expression that I have in yellow, this one here, okay, you can write it in short form as this. Okay, so you just get the x there without the square, and then you get whatever will be inside these brackets with the sign that it has. Okay, so for this one here has a plus, because I cannot say any negative, so this is a plus. So plus 7/2, and then you put these 2 in brackets, and then you square. Okay, and then what are you going to remain with? Because this yellow part here has gone and has become this, we are going to remain with this guy outside. So minus, and then we have 7/2 squared, and then plus 10 is equals to what? To 0. Okay, and then from there, what are we going to do? We are going to write this the same way. Okay, I hope you guys are following. If you're not, please tell me to explain again. And then here we are going to square this guy now. So 7 multiplied by 7 to be a 49, divided by 2 multiplied by 2, it's just a 9, and then plus 10 is equals to what? To 0. Okay, and then from there, we can say x plus 7/2. Then we can add this now. Okay, we can add this. So that's minus 49/4 plus 10. Okay, so here what we realize is that we can write this in the following way. Okay, so this 10 here, so that we can simply simplify these fractions, we can write it as a 40/4. 40/4 is the same as 10, right? So we're not changing anything, we're just writing 10 in a new way so that we can add these fractions easily with the common denominator there. If you want, don't change, you can just say over 1 and then you add them, right? Okay, but if you do this, it will be easier. So this will be x plus 7/2. I forgot a squared here. Of course, the squared, and then minus 49 plus 40. And then I'm dividing this by a common denominator, which is 4, right? Then this should be equals to 0. Okay, and then from here, we can see that what we are going to remain here is minus 9/4. So we have x plus 7/2 squared minus 9/4, and then is equals to what? To 0. But we see that I can take this minus 9/4 to the other side. I can take it to this side, okay? So that it becomes x plus 7/2 squared is equals to, then I have 9/4. And then once I reach here, remember my aim is to solve for this x. I'm just going to take the square root of both these sides, okay? So I'll say the square root of this guy and the square root of that guy. So whenever I take the square root of this, it means this 2 and this square, they're going to cancel. So I'm going to remain with x plus 7/2, and then is equals to, now on this right-hand side, since we have introduced this square root here, we are going to say the answer that is going to give us will be plus or minus, okay? Then you have 3/2. So this is what we get, and then our x will just be equals to, we can take this guy here and move it to the other side. So it will be minus 7 over 2 is plus or minus 3 over 2. Okay, so we see now we can have two x's here, one with a minus, one with a positive. So the other one will be minus 7 over 2 plus 3 over 2. And then the other one will be what? Minus 7 over 2, then minus 3 over what? 2. So from here, we see that we are going to get what? We're going to get what here? So this is 7 plus 3 to be minus 4, and then divided by 2, which will give us our minus 2, just like before. And then here, it will be minus 7 minus 3, which is minus 10, divided by 2, which will be equals to what? Minus 5. Okay, so you can see that the answers are still the same. It's still minus 2 and minus 5. Okay, so we've used 3 methods here, but we're still getting the what? The same answers. Okay, all right, so you can choose any method that you want to solve any quadratic equation. Okay, I've shown you the factor, I've shown you the formula, I've also shown you the what? The completing the square method. Okay, so any questions there, guys? Any questions there? Okay, all right, so let me pick another question there and try to solve it using the completing the square only, because I know you can solve the factor, you can solve the quadratic formula. So let me focus on completing the square here. Okay. Yes. Yes. What's your question?
Sir,
Yes.
what of if, like for the, what of if on the square root side, where there was 9 and 9 over 4,
Yeah.
the square root of 9 over 4. Let's say if we had 5, how do we do it there? If it was 5 over 4. Yes, sir. If it was 5 over 4.
Okay. So let's say we have the square root of 5 over 4 like this. Right?
Yes, sir.
Okay. So there you realize that 5 does not have a perfect square root. Okay. 5 does not have a perfect square root. So you can leave your answer just like that. Okay. So you can say, let me write it down. Okay. So if we had the square root of 5 over 4, okay, on the other side. So this one here, you realize that the 5 does not have a perfect square, but the 4 has. So if you want, you can leave it the way it is, or you can do this. You can distribute the root to the 5 on top and the root to the 4 below there. Okay, so you can have your answer as root of 5 divided by 4. So this will be plus or minus, and then you add whatever you have here in front. Okay, so it means your answer there will be in the form of a radical. It won't be just a number there. It will have a radical because I can see the what? The root of 5 there. Okay, so if a number doesn't have a perfect root, just leave it like that. Okay, just leave it like that.
Okay, thank you, sir.
Right. Okay, let's try to solve the other question there using completing the square. Let me get the one that has a coefficient in fact of x squared. Yeah. So this one here is good. Let's get this one. So we have 3x squared plus 7x plus 4. Okay, so we have this equation, 3x squared plus 7x and then plus 4 is equals to 0. So we want to solve this using completing the square, because I know you can solve using the factor method and the quadratic. Okay, so let's use completing the square. So I said when you're completing the square, always make sure that the coefficient of this guy here, the x squared, is 1. Okay, if it's not 1, then you have to make it 1. Okay, so in this example, we can see that the coefficient there is 3. It's not 1. So what are we going to do in order to make it 1? We're going to divide everything here by 3. So you divide everything here by 3, including the number that is there, which is the 0. So if I divide this by 3, I'm going to have what? X squared, then plus. Here, if I divide it by 3, I'm going to have 7 over 3x. Okay, and then 4 over 3. If I divide by 3, and then on the other side, 0 divided by 3 will still remain 0. Okay, so this is the first step. You have to make the coefficient of this guy here to be 1. Okay, so we have done that. And then the next step is just to create a what? A special 0. So we are going to say x squared plus 7 over 3, and then x. Okay, and then we are going now to say plus. Okay, we create the special 0 now. So we are going to get this coefficient of x, and then we are going to divide it by 2, okay, and then square it. So this is what we are going to say. We are going to say 7 over 3 divided by 2, and then we square it, okay? So this is the first part of the 0, and then the other 0 is just the same thing, but with a minus sign in front. So we're going to say minus 7 over 3 divided by 2 squared. Okay, so we've created our special 0 here, and then we can add this now plus the 4 over 3, and this will give us what? 0. Okay, and then from here, we realize that these 3 terms here create what we call as a perfect square, right? I'm sure I remember. So these ones here, they form what we call as a perfect square. Okay, so how do you add a perfect square? You just get the x from this x squared, you write it, and then you get whatever is inside here. So what is inside there is the 7 over 3 divided by 2. So what is 7 over 3 divided by 2? It's the same as this guy. So 7 divided by 3 divided by 2, okay, is the same as 7 over 3 multiplied by what? By half. Okay, so here I've just changed. This there has gone down, the one that was down here, because this is like this, has gone up. You know this mathematics, right? So this will be 7 multiplied by 1, which is 7, and then 3 multiplied by 2 to be 6. Okay, so it means inside here I have a 7 over 6. Okay, and then brackets, and then I put the square outside like that. Okay, then minus. So it means inside here again, since it's the same thing, we're going to have a 7 over 6, and then squared, and then plus 4 over 3 is equals to what? To 0. Okay, and then from here, let's try to simplify things. Okay, so we can say x plus 7 over 6 squared minus, what is 7 squared? We know that it is 49, divided by, what is 6 squared? To be 36, and then plus 4 over 3 is equals to what? To 0. Okay, so we realize that we can add these guys here. So the minus 49 over 36 plus this guy here. Okay, so we see that the common, let me write it here, the common denominator there will be 36. So 36 into 36 to be 1, 1 multiplied by minus 49 to be minus 49. And then plus 3 into 36, it will be 12. Okay, so 3 into 36 is 12. And then that 12 multiplied by this 4 here to be what? It will be 48. Okay, so this will be a 48 like that. So we see that this one will just be minus 1 over 36. That's what we get when we add this, right? I hope you're following. So let's continue here. So x plus 7 over 6, and then we say squared is equals to, since here it was minus 1 over 36, which is this thing I wrote there. When we take it to the other side, it will just be 1 over what? 36. Okay, and then from here, we can take the square root of both sides. Okay, we can take the square root of both sides. So square root this side, even that side, square root it. Okay, so here we're going to remain with x plus 7 over 6 is equals to, okay, So here we have 1 over 36. We realize that 1 has a perfect square, 36 has a perfect square. So it means this will be plus or minus 1 over 6. Okay, so our x will be equals to minus 7 over 6 plus minus 1 over 6. Okay, so meaning we have 2 x's from there. So the other one is minus 7 over 6 and then minus 1 over 6. Then the other one will be minus 7 over 6 and then plus 1 over 6. Okay, so let's add these fractions. So they have the same denominator there. So meaning we can just concentrate on what is on top there. So what is on top there is minus 7 minus 1, which is minus 8, divided by 6. We can reduce this to 2 divided into the I to be minus 4, and then 2 into the I to be 3. So our first x is minus 4 over 3. And then here we are going to have what? We are going to have minus 7 plus 1, which will just be minus 6. Then we are dividing by 6, which will give us what? A minus 1. Okay, so you can see our two answers clearly there. The first one is this, then the other one is that. Okay, so any questions there? Okay, no question. Okay. All right, so that's how you use the completing the square when you are actually solving a quadratic equation. Okay, but now let us look at how we can apply the concept of completing the square. How can we apply it? That's what we want to do next. Okay, so we can apply it when we are actually graphing these quadratic equations. Okay, so you can graph the quadratic equation in the normal way. Okay, or you can use the what? The completing the square method. And when you use the completing the square method, it will be very easy for you to graph it. Okay, so let's look at that question now. So these ones here, you can try them out. I've shown you how to do it. So let's look at number 3 here. Okay, so we are applying the completing the square concept now to sketch quadratic functions. Okay, so they are saying complete the square on each of the following quadratic functions. And then they are saying hence sketch, okay, the graph of the function showing clearly the x, the y intercepts, and the turning points, okay? And then after you sketch, they're saying state the line of symmetry, and then 2, state the maximum or the minimum value of the function. Okay, so we are going to use completing the square to do this, okay? So I'm going to pick one example here. Let's say the first one here. So on A here, I have x squared minus 5x plus 2. So let's complete the square on this guy and then sketch, okay? So we have f of x is equals to x squared minus 5x and then plus 2, okay? I hope I'm remembering this the correct equation. Okay, so this is the function that we have. So we want to sketch this function, but using completing the square method. Okay, so what are we going to do? What are we going to do? Okay, so the first thing I said is to do what? To check if your function has a 1 in front of the what? X squared. Okay, so we see that this function here has a 1. Okay, so we can complete the square. So we're going to say f of x is equals to, we are going to write x squared minus 5x, okay? And then now we are going to write that special 0 here. So how do we write that special 0? We say plus the coefficient of this x divided by 2 squared. So we are going to say the coefficient there is minus 5 divided by 2 squared, okay? And then we're going to write the same thing but with a minus sign in front here. So we're going to say minus, and then we're going to write the same thing. So 5 over 2 squared, and then we have what? Plus 2. Okay, so now notice here that we are not solving the equation to find the answer. We are just completing the square because it's not equals to 0. You can note it's equals to what? F of x here. Okay, the other ones we are finding the exact values for x, but here we're just expressing it in terms of the completing the square. Okay, so from here, what do we see? We see that what we have here on the middle here is a special 0, right? Okay, but if I pick the first 3 terms there, I'm going to come up with what I said is what? A perfect square. So if I pick these terms here, the first 3 terms here, okay, I'm going to come up with what we said was a what? A perfect square. Okay, so a perfect square, how did we handle it? We said we get the x from here. We're going to say x, and then we're going to get whatever we have in the brackets here with the sign that it has. So this is minus 5 over 2. So we're going to get it the way it is, minus 5 over 2. And then we put these in one bracket, and then we say what? Square. So all this yellow part here has condensed into this guy here. Okay, and then outside we have minus. And then what do we have here? We have minus 5 over 2 squared. So we can square the 5. Minus 5 multiplied by minus 5 is going to give me a 25. And then divided by 2 multiplied by 2 is going to give me a 4. And then I have plus what? 2. Okay, so it means my f of x, remember it is the f of x that is this side like that. Okay, so my f of x is equals to x minus 5 over 2 squared. And then we can add these two guys here. We can add this, okay? So we notice that we can write these two as 8 over 4, just to make the adding simple here. Okay, so I can write minus 25 over 4. Then these two, I can write it as plus 8 over 4. Okay, so 8 over 4, it's still 2, guys. So I'm not changing anything. I just want the addition here to be easier because I have the same denominator there. So it means what am I going to have there? I'm going to have 4, okay, and then minus 25 plus 8. Okay, if you want, don't do this. You can just simply say over 1, then you get your common denominator and then you add. Okay, so this is what I have here. So this will give me what? So it will be x minus 5 over 2 squared. Okay, and then here let's do the addition now. So it's minus 5 plus 8. What is minus 5 plus 8? What is minus 5 plus 8? It's, is it minus 17? Somewhere there. Yeah, so minus 25 plus 8 is just minus 17. So this will be minus 17 over the 4. Okay, so where we have reached here, we have completed the square. Okay, we have completed the square. We have expressed this f of x in terms of completed the square what? Form. Okay, so from this form now, which is the completed the square form, we can get our turning point. Okay, we can get our turning point, and we can also get our line of symmetry, and we can also get the what? The maximum value or the minimum value. Okay, so what can I say? So if okay, I think let's sketch first. Yeah, let me not mention this. Okay, so how do you get your turning point from here? So a turning point, guys, remember it's a coordinate. It's just x, comma y. This is a turning point. Okay, so how do we get this x coordinate of a turning point? How do we get this y coordinate of a turning point? Okay, so the x coordinate of a turning point, you get whatever you have in these brackets here. You equate it to 0 and then you solve for x. So we are going to say x minus 5 over 2 is equals to 0. So meaning what? X is equals to 5 over 2. So this 5 over 2 here will be our x coordinate of the turning point. Okay, so 5 over 2, comma, and then how do we get the y coordinate of a turning point? we just get whatever is outside here, whatever is outside the brackets here, it's our y coordinate. Okay, so we can say our y is equals to minus 17 over 4. Okay, so we are going to say minus 17 there. Then we divide by what? By 4. So this is our turning point. Okay, so you can get our turning point from where? From the completed the square form. Okay, and then I also said you can get the line of symmetry. Okay, line of symmetry. So line of symmetry. Okay, what are we writing? Symmetry. You finish the spelling, you guys, you are intelligent. Okay, so line of symmetry is just the x coordinate of the turning point. That's the line of symmetry. So it's just the English there, just trying to play with the English. Okay, so the line of symmetry is just the x coordinate of the turning point. So this guy here, x is equals to 5 over 2. This is the line of symmetry. Okay, why is it the line of symmetry? I will explain when I come up with the graph. Okay, so we have found the line of symmetry, which is x is equals to 5 over 2. We have found the turning point. The other thing that they said there was to find what? The x and the y intercept, and then the minimum or the maximum value. Okay, so let's find the x intercept. So how do you find the x intercept? Okay, you find the x-intercept by doing what we are doing per first part. Okay, where here where we had f of x, we had a 0. Okay, so you say f of x is equals to 0, and then you solve this equation. You solve for the x. Those are the x-intercept. So let's find the x-intercept. So x-intercept, it means my f of x, okay, or my y is just going to be what? 0. Okay, so it means I have this equation here being equal to what? To 0. So let me write it here. So I have x minus 5 over 2 squared minus 17 over 4 is equals to 0. So this is a good example. The one who asked, what about if it's not a perfect square? So you get to deal with such equation here. So it means this will be x minus 5 over 2 squared is equals to 17 over what? 4. Okay, and then from here we said we can take the square root of both sides. So meaning of square root there, even here of square root. So the 2 and the square cancel. We are going to have x minus 5 over 2 is equals to plus or minus the square root of what? 17 over 4. So since 17 does not have a perfect square root, you can leave it like this, or you can distribute this square root to the number which is on top and the bottom. So on top, we are going to have root of 17. Down, we are going to have what is the root of 4? We are going to have 2. So you can write it as this, or you can write it as this. Any is acceptable. Okay, so meaning here my x will just be equals to 5 over 2 plus or minus, I'll use the square root of 17 over 4. Okay, so it means your first answer there will be what? Will be x is equals to x is equals to 10. Maybe we should use this one because I have a 2 here and a 2 so that we can add them easy, right? Yeah, I think let's use that one. So let's use that one to be more easier. Okay, so let's use the root of 17 over 2 here. Yeah, so that's all that. Our first answer will be 5 plus the root of 17 divided by 2. So just have 5 plus root of 17 and then divided by 2. Or the other one will be x is equals to 5 minus the root of 17 divided by what? 2. So these x values that we found here are what we call as the y-intercept. I mean the x-intercept. Okay, and then the y-intercept is not hard. You just go back to your original function and then you get the constant. Okay, so what I mean is that you go back to the original function. Where is the original function? So this function here that we have here on top here, just go back to this one, you get this constant here. That's the y-intercept always. Okay, why? Because when we're finding the y-intercept, then x should be 0. So if I put 0 here, 0 here, I'm just going to remain with the constant. So always the constant is the what? The y-intercept. So the y-intercept here will just be 2. Okay, so it means I found all the things that they wanted in that question. Okay, so I can sketch, and then after I sketch, I can mention whether I have a maximum value or I have a what? A minimum value. Okay, so to sketch, we need the turning point. Okay, we need the x-intercept and we need the y-intercept. So let's write them down here. So the y-intercept was what? 2. And then the x-intercept, we had 2 of them. One was 5 plus 17. That should be root of 17. Okay, that should be root of 17. So 5 plus root of 17 divided by 2. Then the other one was x is equals to 5 minus the root of 17 divided by 2. Okay, and then we also have the turning point. Okay, so what was the turning point that we found? Yeah, the turning point was 5 over 2 comma minus 17 over what? So this is our turning point. Okay, so we need these 3 things in order for us to sketch. So we are going to say now, let's sketch. So this is my y-axis. Let me draw it properly. Okay, so this is my y-axis, like that. Okay, and let me put my x-axis somewhere there. Okay, so this is my x. And then we can plot those numbers that we have now. Okay, we can plot those numbers. So we have the y-intercept at 2. So this is 1, 2. So here we have the y-intercept. And then we can put these numbers anywhere here. Okay, so what is the root of 17? Okay, root of 17. So you can estimate. So the root of 16 there is 4. Okay, the root of 16 is 4. So meaning the root of 17 will be 4 point something, right? So 4 point something. So 5 plus 4 point something and then divided by 2, it will be a positive number, right? So it means the first x-intercept can be somewhere there. So you say this is my 5 plus, in fact, should be way above. Okay, should move in front. So it means that 5 plus 17 plus the root of 17, I mean, divided by 2 should be somewhere in front of this guy here, because this one we are subtracting, but this one we are adding. Okay, so this is 5 minus 4 point something. So 5 minus 4 point something, it will still be a what? A positive number. Okay, so we write that 5 point something, we can write it here. So this is just a sketch, so you don't have to be accurate with your plotting. Okay, so this is my first x-intercept and then my second x-intercept. Okay, and then now we look at the turning point. Okay, we look at the turning point. So this turning point here, 5 over 2, this is like 2.5. And then minus 17 over 4. Okay, it's 4 point something again, right? Because if I did minus 16 over 4, I'll get minus 4, right? But I have it's minus 17, so it will be minus 4 point something. Okay. Okay, so we see that this 2 point something here is between these two numbers here. It's between these two numbers. So we can say the 2 point something is here. And then we go down to the minus 4 point something, which can be somewhere there. Okay, so this is just a rough sketch. Okay, so here now you have your points to sketch the graph. So you can sketch the graph now by just joining those points with a smooth curve. So it will be this curve that starts from there, passes through there. Okay, forgive my curve, but yours should be smooth, and then it goes like that. Okay, so here should be smooth like that. Okay, so this curve here is for whatever function that we have. Okay, and then remember we said the line of axis is just this x coordinate. Okay, then the line of symmetry. So how or why is the x coordinate of a turning point the line of symmetry? Okay, so this is the reason. So line of symmetry simply means you are dividing something into two equal parts. Okay. So when I draw a line here, now I haven't drawn it properly, but I hope you get what I mean. Let me try to draw it. Okay, so when I draw a line there proper that passes through this x coordinate of the turning point here, you realize that this curve here will be cut into two, with this part that starts from here and goes, and then even this part that starts from here and goes this side. Okay, so these two parts here will be equal. No wonder we are saying that this here is a line of what? Symmetry. So the line of symmetry is just x is equals to 5 over what? 2. And then they also asked us to find the maximum or the minimum. Okay, so if you have a curve that is facing up like that, it means the value that is there for the y is the minimum. If I had a curve that faced up like that, it means the value that is there of the y is the maximum. So in this case, since we have a curve that faces up, okay, we are going to say minimum value, just write mean is equals to the y coordinate of the turning point, which is this guy here. Okay, so minus 17 over 4. This is the minimum what value. And then we said the line of symmetry is just the x coordinate of the turning point, which is this guy here, which was 5 over what? 2. Okay, so that's how you sketch using completing the square, and you're also required to find the minimum or the maximum and the line of symmetry. All right, so any questions there?
Hello?
Yes. You have a question?
When you were solving for the quadratic, when you're completing the square, where did the -5 go?
Which -5? Let me go back. Which -5?
-5x. Where
Negative.
did it go?
Oh, okay. I know where you are. This one here.
Yes.
Yeah. So I don't know if you are there at the beginning of the class. Okay, so we said these three terms here form what we call as a perfect square. Okay, and when you're forming a perfect square, you just simply ignore the term that has x. You concentrate on this guy here and this guy here. So this one here, you just ignore it.
Okay.
Yes. Okay. But if you were to expand this, okay, if you were to expand this x minus 5 over 2 squared, if you were to expand this, you will still get this same expression here with the 5x included. Okay. But we know that this one here will form a perfect square. So we ignore the term with the x. We ignore the term with the x. We just concentrate on these two that have to match squared, these ones here. Okay. Okay, so that's what we always do.
Thank you.
All right, you're welcome. So any other question, guys? I think I'll end here for today. Okay, no question. All right, so thank you very much for attending the class. Shall continue this week the classes. Okay, so those who want to register with us, you are always welcome to register with us. Otherwise, have a blessed night.